All right, thanks so much. Well, as you said, I'm Dan Staples, and I work for Siemens. And many of you probably already know Siemens, one of the biggest companies in the world, one of the most respected companies in the world. And you probably know us for our world-class engineering, whether that's trains or windmills or other types of automation equipment. But we also make world-class software. And in fact, there are literally thousands of engineers around the world right now, software engineers, writing software to make our world a better place. And in fact, I would venture to say that you have used our software. So if you've used any of the products you see up here, and I would bet that most folks in this room have, SolidWorks, Pro-E, other things, those all have, in some part, Siemens technology inside them. So we build the geometric modeling kernel for many of these products. We build the 2D solvers and 3D solvers for many of these products. So you're used to Siemens technology already in some measure. If, however, you want sort of the full stack of Siemens technology from top to bottom, you're going to find that in our NX product or our Solid Edge product. But I'm not going to talk to you completely about products today. I want to talk to you about things that affect you as a business. And what I want to talk to you about particularly is disruption. So we're all familiar with the term disruption, a disturbance that interrupts an event, process, or activity. But what do we mean in the context of business? And here I'm talking about disruptive innovation. Now, this is a concept put forth by Clayton Christensen probably about 20 years ago. Clayton Christensen's a professor at Harvard right here in Boston. And it has the following notion that if you look at time marching on and performance getting better, what you're going to see is that industries tend to settle into this pattern. And this pattern says, well, we continue to improve our products, and those products incrementally improve across the industry. Products get better and better over time, and we all expect that, and our customers are happy. But what happens, and it happens again and again, is disruptive technology enters, and it accelerates on a different curve at a different rate. And what you see is that they intersect, and sooner or later that technology surpasses. So if we're sitting here on the right-hand side of the graph, you have to ask yourself, do you want to be on the upper curve or the lower curve, right? Is technology disrupting you, or are you driving disruption? And so this all starts, let me tell you just a little story about a company that has seen this curve. So back in 1998, there was a small company, 2D design, wanted to get to 3D, happened to choose Solid Edge for that purpose. They're working on this product you see here, which frankly in 2D you may go, what the heck is that? Well, they have since, through a digital strategy, grown to be a $4.4 billion company using a wide variety of Siemens PLM products, and they are literally engineering powerhouse these days, making many more products than just the product that they're famous for, obviously, the vacuum cleaner. But you've seen many of their products throughout the world today. So is this a one-time thing? Is Dyson unique in this way? And I would submit no. I would submit that today's small and medium businesses are in fact going to be tomorrow's leaders. And there's a lot of evidence that supports this. So I find this rather surprising, and I think you might too. So if you're familiar with the S&P 500, the S&P 500, the 500 largest companies in the United States, those 500 largest companies, in 10 years, it will not be the same 500 companies. In fact, 250 of them will have fallen out of the S&P 500, and 250 others will have taken their place. And this pace is accelerating. So if we look back at 1965, you were in the S&P 500, you might expect to be there for a lifespan of about 33 years. And as you can see on this chart, what we're seeing as we go forward, that's going to come down to 10 years. So you see this type of churn where disruptive technologies are coming in, companies are growing from that and displacing other companies. So you have to be thinking about which end of that curve you want to be on. And so as I talk to you about this, I want to talk to you about three different things. The first is innovation itself. So interesting statistic, 16 times more patents filed per capita by small businesses than by large businesses. So I often think of large businesses as doing a lot of innovative engineering, and indeed they do, but small businesses are filing more patents and fostering and driving that innovation. They're where that disruption is coming from. There's a lot going on in cloud or no cloud. Cloud's been growing at a high rate of speed in a lot of industries. There's a lot of discussion about it here, and we'll talk some about that. And then finally, how do you access the software? You're going to talk to people at this conference who are going to say, you'd like to have my software, that's great. You'd like to buy it? I'm sorry, you can't buy it. You can rent it. You can subscribe to it, and The secret, of course, is when you stop paying that bill, you stop using the software. And we don't think that's quite right, and I want to talk to you about that as well, because it can be very disruptive to your business, frankly. So let's start with the first bullet here, fostering innovation. And I want to tell you that innovation is the lifeblood of your business, of your design and engineering business. And the fact is, most of you in this audience are using technology that literally is 20 or 30 years old. And what I mean by that is the history tree. Look, I know and love the history tree. I used to have a history-based model that was all solid edge was for many years. But the problem with that is, as we all know, that you get locked into a certain design pattern. It becomes very difficult to make changes. And frankly, the fact is design is not linear. I did a talk on this about 2 years ago at Develop 3D in UK. The best designs are not when you come up with an idea and go from A to B. They're where you go from A to B and come back and go to C and D, and you iterate and you come up with a much, much better solution. And when you're locked into a certain design because of the history tree, you're not able to do that. So if I had, for example, what you see up here, I'd worked on this design on the left, very kind of chunky kind of design, and I was at a certain point, I'm like, hey, I have this idea that I could improve it or take a different manufacturing approach, do it cheaper, maybe better. How would I get from A to B? If you're like me and you're a history-based person, you would say, I will start again. There's not any sane history-based person in this room who would go from A to B by modifying the model to get from A to B. But I will tell you that, in fact, you can modify the model from A to B in under 2 minutes. And if I were sitting in the audience, I would say, well, you're crazy. Show me that that's possible. So I will. So we're going to take the model from A to B. I've sped this up by 2x, but the clock over here is real time. Okay, so this is going to clock under 2 minutes as I make these changes. And what's really important about this is not really each mouse click he does, but really the fact that he's able to change his mind and come up with a better design as a result. So here we are 40 seconds in. He's already got a lot of the structure completed. Rounds up a few things, adds a few more rounds. And so if you want to be innovative, if you want to be the disruptor, you have to be able to create better designs faster. You cannot create better designs faster if you're locked into that history tree and can't do what you need to do. You don't need your design tool to be constraining you. You need your design tool to be doing what you ask it to do. So we just have a few other things to finish up here. We're going to pattern this around very quickly. I'm going to start editing the other part. Notice I don't have to change environments. I don't have to go anywhere. I'm going to edit 2 parts at once. And here we are, minute and 52 clock time, A to B. It's all about the ability to innovate more quickly. But advancement never rests. And so we've been working on a lot of other very interesting technologies. And you've heard about several of these throughout the conference, and I'm sure you'll hear more about them. Reverse engineering, growing very fast, 10% a year for a long time, continuing. We've heard quite a bit about generative. I know Jesse from Frustum spoke yesterday. Amazing technology in Frustum. And that's going to continue to grow. And additive manufacturing. You can't throw a rock without hitting an additive manufacturer next door. Definitely growing in the industry and going to continue to grow. So I want to talk a little bit about all 3 of these. Now, the thing about it is, those are all powerful technologies, and I think it was the prior speaker that mentioned the fact that they were mesh-based, or perhaps it was the one before that. If you look at these blue circles, these are mesh-based technologies, meaning it's a bunch of triangles stitched together in some sort of mesh. And so generative, reverse, additive are all mesh-based. But the CAD you use today, whether it's any of those systems I showed you earlier, are not mesh-based. Those are typical solid modelers, and so they're BREP-based, or let's just call it traditional solid modelers. And so what you'd like to have it do, though, is for all this to work together. Generative and reverse flow into my design, flows into additive manufacturing. But it doesn't quite work that way in general. So even if generative design can create a perfect shape, you're going to find that most tools you're seeing here create a visual idea of what you could actually do, but then you have to do the hard work of actually creating that model for final purposes. Same thing in reverse engineering. It turns out the scanning has become the easy part. Scanning and getting a mesh is the easy part, but then you have to put all these surfaces on it to make it a BREP so you can bring it into your CAD system. And additive manufacturing has so much potential, but how are you going to get the parts that are interesting enough to take advantage of that? So let's start with the reverse engineering piece. So here we have a Bernina sewing machine from the 1800s, and we take a scan of that arm we're going to do a little bit of work on this and try to bring it into the modern era. So as a scan, it's just a mesh. I need to operate on it. Here I am in Solid Edge. I'm going to say I need to get rid of this hole. I remove it, and because obviously it's just a mesh, it leaves a gaping hole. So now we've got to fill that back in. We're going to fill it back in. Super easy. But as I said, you want to start bringing this into a CAD system. You need to generate some analytic geometry that you're going to use as solid model-y kind of stuff. So I'm going to generate a cylinder, for example. Simply paint an area and say I want to do that. There's also an automatic method. Or paint an area and say I want to turn that into a plane. Now, you can imagine this is going to take me a while to get around the whole model and do all that. But that's going to be completely unnecessary. And I'm going to tell you why in just a second. Next up is generative design. And I want to show you this because it is quite different. As Jesse was talking about yesterday, there are different flavors of generative design, and the one you're going to see from Solid Edge and NX is quite amazing. So here we are with the more modern Bernina sewing machine, which is literally a work of art. And what we're going to do is just give it a design space. I'm going to redo this frame. I'm going to tell it a few things. I'm going to tell it the places where I'm going to mount to it. And so I want to keep those areas, and I want maybe a little collar of material there. So I'll just fence an area and say, hold those 3 holes, and I got a hole here and a hole here, and I might go around the model identifying other holes that I want to keep and put a material collar around. And then I have to put some loads on it. So there's some load because of the spindle, and I have to put some constraints on it. There's a constraint at the base. How fast do you want it to run versus how quality do you want it to be? How much weight do you want to remove? All those kind of things. And this would run for a little bit of time. And it would come back with what I consider to be a truly amazing result. And what's truly amazing about this, and I'm going to say this probably a couple times, is this is a fully finished part that you could print out and it would be ready to go to production. You could use it in your sewing machine tomorrow. So it's not a part that kind of gives you an idea of and has a bunch of crufty stuff and warts on it, and then you're going to go do a surface model. This is actually ready to go as you see it here. And so I invite you to look at generative design closely, but not all generative design is created equal. Additive manufacturing. A lot of stuff going on in the space. You heard a lot of that from the prior speaker. And Solid Edge is continuing to push that forward, whether that's the new 3MF format, printing directly from your Solid Edge device to a printer that's connected to your Solid Edge machine, say. Most exciting thing, I think, though, if you've ever used Kayak or Booking.com or Trivago, and they kind of aggregate all these providers, most of you don't have a 3D printing machine out there. What if you want to get something 3D printed in titanium, stainless steel? You simply go into Solid Edge and say, I want to print this. Tell me who could print this in what material. Bunch of materials, pick the material I want. Okay, I'll tell you 5 or 6 providers of that. Not only will I tell you who they are, I'll tell you their lead times and prices. So now I compare the prices, I compare the lead times, and when I hit go, literally your model is sent securely and comes back in a couple days as a physical part. So this is a great thing. If you've seen all this here at the show and you're hearing all about additive and you're like, that's great, but I'm not ready to go get a 3D printer. Just use this kind of service to push it out there, get your part back, start to dabble. And of course, they have all the materials you might ever need. So we've got those 3 great technologies, but we still have kind of these islands, if you will, and we want to connect those islands together. So there's a final magic piece here, Siemens technology, called convergent modeling. And you haven't heard anybody else talking about this technology. But it's basically the idea that I can integrate the solid model, let's say the red you see here, and the mesh model, and I can operate seamlessly between the two. And you can't even really tell the difference between the two. So I'm going to show you a video here. And it's going to look unremarkable because you're going to see feature modeling. But what's remarkable about it is you're seeing feature modeling on a mesh. There's no solid model here. And so try to bear that in mind as we look here. So back to our arm here. I need to punch this hole through it because it's a different size or something. Punch this right through the mesh model. I need to put on a part number. I'm not using any special commands here, like use the mesh special command. I'm just going to do an emboss part number, comes up automatically using the same command I do in Solid Edge for feature-based modeling. Take a BREP part or a regular solid model, use it to difference out, and then make edits to that. So again, I think the magical thing here is it doesn't look magical, right? It's just feature-based modeling, but on a mesh-based model. So what that lets you do uniquely is close this loop and tie it all together. so that it really does flow the way you would all expect it to. You can have your print-ready generative designs, but if you want to make more changes to them, you can go right in there and change them like you saw. You can reverse engineer that and only put on those two surfaces, assemble it in, and then do more feature-based modeling on it. And so you really have the ability to realize the power of additive manufacturing. Now we got to bear in mind though that this goes beyond design, and we talked about this, a couple other speakers talked about it. So design, simulation, manufacturing, tech pubs, data management, really any of these things are available to you in the Solid Edge portfolio. So next up is this cloud thing. Cloud or no cloud? And I will tell you, I think we take a very practical approach to this where we don't think it's an all-in thing or an all-out thing, but something that's a nice bridge for our customers. And so we started this a couple of years ago, and we introduced Solid Edge streamed from the cloud. One of the great applications of the cloud is you want to try Solid Edge. Everybody in this room wants to try Solid Edge. I just know it. And so if you want to try Solid Edge, you can do so by streaming it from the cloud to your browser. Nothing to install. You just go say you want to try Solid Edge and can use it right in your browser today. We started with version ST8. Our latest release from the summer is available. So that's kind of our first step in the cloud. Second step was last year, something called Cloud Enabled. So one of the great things about the cloud is that sort of you can access it from anywhere thing. And so what do you want to access from anywhere? Well, I want to access my powerful desktop Solid Edge, but I want to access it on this machine, and I want to access it on that machine, I want to access it on that machine, and I've got one license. Well, I can do that because the cloud can follow me around, right? I can get my license and my settings through the cloud and automatically be able to take advantage of that power of the cloud. And of course, we're very compatible with Dropbox, OneDrive, and other such things, which allows you to take your files with you anywhere you go as well. Now, very excited to announce something new, the Solid Edge Portal. And this is about cloud collaboration, again, trying to take advantage of what the cloud is good at. And this is web native in a browser collaboration. So you can take your files, upload them securely to the cloud to share with your customer or supplier for view and markup. And they're in the cloud, and you guys can each access them and do your view and markup. Now, really important point here is the last bullet there. It's the Solid Edge Portal, yes, but does it support Solid Edge files? Yes, it does. Does it support NX files? Yes, it does. SolidWorks, Pro-E, Inventor, even AutoCAD DWG. All of those file types are supported. So if you're in the crowd and you're a SolidWorks user and say, I want to collaborate with my supplier, instead of emailing your drawings around or using Dropbox, you can put them on the Solid Edge Portal. It's completely free, and it includes both the viewing and the markup. So very excited for this particular new use of cloud. Quick demo of that. So here we are, happen to be on a Surface device, but it actually could be an iPad, whatever it might be. And I want to upload some data, so I'm going to browse on my local device and find my data and say I want to upload it to the cloud. It's securely uploaded. And then you define who you want to share it with. And do you want them to be only able to view it, protecting your IP, or they can view and download it if they're a very trusted partner. We take advantage of the power of the device. The devices these days are very good at rendering triangles, even the phones. So in this case, I've got my Samsung smartphone, Android-based device. Could be an iPhone, doesn't matter. UI adapts, and you have the capability to view that exact same part on your smaller device. And this is a great application, actually, these smaller devices. They're not great for content creation, but they are great for content consumption. And so we think this is a really good way in which to use cloud. So what will we do in the future? I think you'll see us do things that are complementary. If you look, you're going to see that there's certain things the cloud's good at. Access anywhere, storage, computing, communication, content. Very good at those things. There's things the desktop's good at. Desktop's very powerful, and plus that's where everybody is today. And so you're going to find us continuing to build out both these technologies and be able to bridge the gap between the two. The most important point is we think this should be your choice. This should not be, oh, you want to run my software? You need to be in the cloud. This should be, you choose how you want to access the software and let us know. So whether you want to stream it from the cloud because you want to try it out that way, you want to work cloud enabled, you want to use the collaboration portal no matter what CAD system you use, you're going to see us continue to work in this cooperative way where it's your choice. The third thing is access choice. And I referenced this earlier, but I'm going to say it again because I think it's really important. If you want to buy CAD software, not rent it, you want to buy it, you should be able to buy CAD software. We're certainly going to allow you to continue to do so. So, do we offer a monthly subscription? Yes, we do. Now, monthly subscription is not appropriate for everyone, and there's certain people it's very appropriate for. It tends to be appropriate for a small business. Small businesses don't have a lot of capital, and they don't want to plunk down $5,000, $10,000 for some CAD, right? They want to be able to just pay on a monthly basis, and that's perfectly fine. We do see most of our monthly subscription is small business. Annual subscription, a little more cost effective. You get a discount, you sign up for a year. Yes, absolutely. And perpetual, as I said, yes, exclamation point. If you want to buy your CAD from us, you can buy your CAD from us. You can go off and be a hermit and not connect to the internet and use your CAD forever. And then free trials, or free in general. So free trials, we made the Solid Edge trial 45 days after working a lot with shorter trial times. 45 days gives you time. Most people like download it and don't even have time to use it, but you've got work to do. Eventually you'll get around to it. 45 days, free trial. And free for startups, absolutely. We think we should be very generous, in fact, in that regard, in terms of how much money a startup is considered a startup. And so we have a really, really good program for startups, and we just see those coming in day by day. And free for students. Of course, here we are at BU, but not only university students. Students of all shapes and sizes and stripes are welcome and free Solid Edge. So middle school student, elementary school students use Solid Edge. You can have a grandmother in continuing education. Solid Edge is free for her as well. So it really doesn't matter. As long as you're a student, Solid Edge is free for you. So all the different ways to access Solid Edge. And I want to just highlight a couple of these because I know that in this particular audience, we get these kind of folks, right? We're going to have quite a few startups in here. We're going to have quite a few students in here, and I want to talk to both those constituencies. So free for startups, I think some really key points here. The first is it's free for every engineer you have. It doesn't matter if you have one engineer or you have 10 engineers. If you're a startup, you get a free Solid Edge copy for every one of them. And it's not a dumbed down version of Solid Edge, it's Solid Edge Premium, our best and most complete package. And obviously, if you're doing some great stuff, we'd like to hear from you, and we'd work together on co-marketing opportunities. Suggest if you are a startup, you should look into this. And I think, again, you'll find that our barriers to coming into this program are very low. So I would suggest you look into it. Typical type of startup that we see, Skybridge, full automation company. It's kind of a big data company. They make very large drones that do agricultural data analysis, and they overlay farmers' crops and figure out where they need to be watering more and so on. Solid Edge startup program, very successful for them. And we've been expanding it throughout the world. We started in the US and the UK, and we've expanded it now to 33 different countries. And what about free for students? Well, yes, it's free for students, but we also need to back that up with programs that are relevant to students. One of the programs that we support with Siemens is called Green Power. And Green Power, to me, if I was a student, would be the most exciting program you could possibly have. You design your own electric race car, and you build your own electric race car, and you race your own electric race car. The gentleman you happen to see sitting here is David Cullimore, who happens to be kind of like the reigning king of the Green Power. So if you look at what he's done, he's obviously used a Solid Edge to do this. You know, won the whole thing in 2012, won the whole thing in 2013, 2014. The list of accolades goes on and on. This is a great example, though, of disruptive innovation and innovating in general. Because what happens is David engineers something and comes up with a clever idea to beat everybody, and he beats everybody. And then they change the rules. They say, oh, no, that was too clever. That's against the rules now. And they change the rules. So next year he has another innovation, and they change the rules, and that's not allowed, right? So he just keeps innovating over and over and winning over and over. And the great thing about this, though, it's not just a story about winning, but it's also a story about growing. So after in Green Power, he became an intern at Red Bull, had an internship at Red Bull, and now he's full-time employed at Aston Martin Racing. So you can really take this software and your innovation and drive yourself to new levels from the garage all the way to Aston Martin. Okay, so those are kind of the three pillars that I want to talk about: innovation, cloud, and access choice. And I'd like to invite on stage to talk with me about those briefly Craig Hall, because he knows a little bit about all of these. So Craig, please join me on stage. And let's give Craig a hand.
Trophy. truck racing is the highest level of the off-road sport. It is the unlimited class, pretty much anything goes, and they're some of the fastest vehicles out there. I'm Craig Hall with Hall Designs. I've raced the Baja 1000 a few times, and in 2012 we ended up winning that race. So to finish is huge, but to win it as a driver and the designer of the car, I don't think I could top it.
All right, so Craig, the reason I want to get you up here, I think you know a little bit about all these things, and I wanted to start maybe with just your Solid Edge journey. So how did you come to get involved with Solid Edge, use it as your tool of choice?
Yeah, so I actually used Solid Edge previously with my previous employer.
Okay.
And we, it's actually a large part of bringing Solid Edge into them as a large sheet metal job shop. And when I took the step to go out on my own, he had just come out with the subscription licensing. And as a new startup and, of course, limited cash, it was the best choice, logical choice.
So really, the fact that it's available on a subscription lets you as a small business do
Yeah, it let me pick the level of software I needed with all the tools that I needed on a professional, program with the low cost of monthly.
And so what about this, the second thing, the cloud, no cloud? So how are you leveraging cloud at all? Is it something that's useful to you?
So I have all my data on the cloud and am cloud licensing, and both are combined together. It's great. I get all my data and all my user settings on all my devices. So I actually have three. I have my office PC. I do reverse engineering at the laptop with laser scanning, and then of course a Surface Pro, or I use traveling or while at home.
So you mentioned the laser scanning, reverse engineering. So this whole sort of next generation design and generative and all that. I understand you're using that in your business. So.
Yeah, so I just use almost all the products now on a new assembly I just finished for a customer with the ST10 release and the generative and convergent modeling. It's really, really great. Like I said, I do a lot of reverse engineering, and the laser scanning typically spend a lot of time and other software having to create surfaces before I can bring that even into Solid Edge. So being able to do the surfaces in Solid Edge on that mesh is just saves a lot of time. And of course,
but now you've done something with generative, right? Because you had problems with different suppliers and lead times and stuff, and you could combine some parts together. And
yeah, so we just finished actually this pedal assembly here for a customer, and this is it seems simple enough as a gas pedal. It's pretty complex. So this is an electronic gas pedal assembly for a trophy truck, off-road race truck, and we specifically set out to use the generative tools in creating this new shape and just a new product for that customer. So combined with the generative tools of just having that cool, unique shape and look, we wanted to eliminate the traditional 2 to 3 machine parts and 5 or 6 lasered parts, and then having those components welded together and then sent out for plating or processing.
Super. So I think, as you see, Craig has his titanium, I think? Aluminum part in his hand here. Also can do that through the printing service and such. If you want to see it, I'm sure Craig will be around here nearby. So thanks so much, Craig.
Yeah.
Appreciate it. All right, so just to bring my section to a close, I want to put a wrap on these 3 things. And what I would really ask all of you to do is not sit here passively and let all this just wash over you and go, I want to develop 3D, that was awesome. You got to do something, right? So what should you do? First thing I would invite you to do is to try Solid Edge, and particularly try it in the cloud, right? You can go while sitting there. You can actually log into the trial page, say, I want to try it in the cloud, and run it directly on your device. Easy to find, just Google Try Solid Edge, you'll come right up with the page. Second thing, we've been talking a lot about generative at this show, and I would encourage you to try it. So try generative when you try Solid Edge for free. Try generative while you're in there. Now, I'm going to point you to a different site here, Udemy. I don't know how many of you know Udemy. If you're a student, you probably do. It's an online university that allows you to access different things. Look for Udemy Generative. And then finally, access on your terms. So if you want to use Solid Edge a little more, get a monthly subscription. And if you're a student, Google Solid Edge Student, or if you're a startup, Google Solid Edge Startups. And I want to see everyone in this audience drive disruption. Thank you.